somewhere in the southern Germany. So may I start? I will start. So hello everyone. A day has only 24 plus or minus 1 hour, but I have less than 30 minutes to speak about it. What I'm going to speak about today, I'm going to tell you how to check the current time in Python, that you shouldn't check the current time too often, and that you should check what your government does. My name is Miroslav Šedivý. I was born in Bratislava, Czechoslovakia, which is the time zone of your Bratislava. Studied in Lyon, in France, which is the time zone of Europe, Paris, and now working in Karlsruhe, Germany, which is the time zone of Berlin. Actually, this is the region of the best German one, the Western beer, the place where both car and the bicycle were born. And if you would like to do some cool stuff with technologies, just contact me and check the game. So it looks like I have spent my whole life in a single time zone, Central European time zone. So am I allowed to speak about all those other time zones around the world? Yes, I will try that. This is a live talk, but my slides were prepared a little bit ahead. So let's say that now it is Thursday, the 8th of October 2020, 10:50 of the Eastern European summertime, there in Tallinn, Estonia, which is 1 hour less here in Germany, and all my following code snippets will connect to this timestamp. If in Python you want to check the current time, you can import a standard datetime module and then date and datetime now, and you will get the current time with year, month, day, hour, minute, second, microsecond in Tallinn. So 10:50. But if I do that on my computer is set to the Central European time zone, I will get a different datetime object that is 1 hour behind your datetime object. If you compare them, there will be 1 hour difference. If my server or my computer is set to UTC, it will return another object. And these objects, they look the same, but there is a difference. Although they were created at the same moment, there is a difference. So if you just store this date and compare them, you will see the differences, although they were created at the same time. If you want to get the same time on every computer around the world, you have to use UTC now, which will return a datetime object with the time in UTC, but actually without the information that you are in UTC. So implicitly, you will have to remember that you are in a UTC now. If you ask for the now current timestamp with the daytime time zone UTC, you will get the current time in UTC with the information that we are in UTC. So that's great. But we are in Tallinn, and it is not 7:50, it is 10:50. We want to know what time is it in Tallinn. So you have to ask the current time in the time zone that is 3 hours ahead of UTC. We are still in the standard library, and you will get this information 10:50 and with the offset of 3 hours, so 10,800 seconds. The problem is that this is valid now, these 3 hours offset, but not in winter. In winter, you are only 2 hours ahead of UTC. You have to remember where you are. And that's the place where you have to catch or where you have to reach for other libraries that will allow you to keep the information that you are somewhere around the world, actually in Tallinn. The classic solution would be the pytz. You can define your current time zone as Europe Tallinn, and the current time will be 10:50 with the information that you are 3 hours ahead of UTC. But pytz is not the best way to work with time zones because it doesn't follow the standards of the implementation of daytime, and there are maybe some problems I will show you a little bit later. And for example, if you have the current time, which is without the information about time zone, so it is time zone naive, 10:50, and you want to tell that this time is actually in Tallinn, if you replace the time zone info with the information about Tallinn, what you will get is the offset will not be 3 hours ahead of UTC, but 1 hour and 39 minutes. Where do this 1 hour and 39 minutes come from? If in pytz you want to do this correctly and you want to localize your time zone naive data, you have to do it this way. So take the pytz object, localize it using it the data, then it will be correct. So we will have the information 10:50 in Tallinn, 3 hours ahead of UTC. Because actually, if you compare these two data objects, you will have this difference. This 1 hour and 39 minutes, we will have a look at that later. If you use Python 3.9, which is very fresh, you can use the zone info module by Paul Gansler. That will allow you to do this stuff much easier. It is in the standard library, and you ask for the current time in Tallinn, and then you can convert, you can replace, and it will work correctly. If you are not in Python 3.9, you can port this zone info, or you can use the dateutil library, which works almost the same. But you see, anything, whether you use this or this, you see that they don't have the information about the time zone themselves. They have to take them from somewhere. And what you see there in the second case, in the dateutil case, in the last line, there is user share zone info Europe Tallinn. So actually, it is somewhere on my computer outside of the Python distribution, the information about the time zones. Quickly to Python, if you want to check or to create the strings with the current date and weekday, and you do something like this, you ask for the current time, convert it to string and another one. This will work, but it will break once a day in a moment where you are probably not sitting in front of your computer. And actually, this will happen at midnight, because if you start these two lines just 1 microsecond or nanosecond before midnight, the first line will get executed on one day, the second line will get executed on the second day. So it will give you inconsistent information. If you want to work with daytimes, with the current daytime correctly, just check the current time, look on your watch once, remember what's there, and then extract all the information. So it means check for the current time only once. There is an exception where you want to check for the current time several times. For example, if you have some expensive operation, something like download, and you want to know how much time it takes, you can check the current time before, after that, and then check or calculate the difference and get the seconds. Actually, the time delta, you can also divide time delta by another time delta, and you will get the same information. But with daytime, it's just a little bit too much overhead, because daytime is expensive to calculate, and you don't need all these years. All you need is actually the difference between two time stamps in seconds. So what you can do is use the time, get the number of seconds since epoch, and then another, and it will work. But this can also break. If during the expensive operation, your computer sets the current time using NTP date, because it was off by a few seconds, and then it will correct it. It may happen that actually your end happens before start on your clock. In that case, you can use monotonic, which is guaranteed to return always a single float referring to beginning of some process. That is not important, because all you want is the difference, and this monotonic is guaranteed to be monotonically increasing. So no matter what happens with your computer clock, this will always increase. Or you can use monotonic in nanoseconds. So this was Python. Now let's have a look at the time zones. How would you check for the time? What you can do is look at the sun at the highest position, that's noon. Next day, noon, 24 hours in between, and that's wrong. Ever heard of a time equation? Time equation, it is, you can see it sometimes on old churches. It looks like an 8, and the 8 represents the offset of the sun's noon comparing to our noon during the year. And in Central Europe, maybe also in Estonia, the offset can move by about 15 minutes plus or minus during the year. So actually, there is almost never 24 hours exactly between two noons. So if we know about that, we can fix that. And then we have something like local time. So now here is noon in Tallinn. In the next city, there is noon a little bit later or sooner, depending on whether it is in the east or west. So this means that with local time, this works locally, but as soon as you start to travel by train, for example, you need something coordinated. Because between two cities in the 19th century, there was a simple track, and you didn't want to send two trains at the same time from both cities, because both of them used the local time. So there are countries that started to keep their standardized time according to their capitals. So, for example, in France, they took the Paris time and they added 5 minutes because these 5 minutes were a gift to the passengers that were too late for train. So the official French time was 5 minutes behind Paris time. There was Greenwich, and some other countries around the world, they adapted to these standards. And actually, you can imagine you have Greenwich and then plus 12, minus 12 time zones all around the world. So 25 time zones, if you're done. That would be easy. And this is actually how Europe should look like according to the time zones. But you know that the whole Benelux, France, and Spain belong to the red zone, so to Central Europe. This is because in the 1940, Hitler invaded the Benelux and France, so they switched to Central European time. And in Spain, they solved it at school and then changed it as well. If you use Python time zone library, for example, you ask for the number of time zones, you will get a huge number, 440. Where does this come from? You see that, for example, in Europe, you have a big blue or big green field of time zones that usually use the same time currently. But this is for historical reasons, because actually every country has their own time zone, although two neighboring countries probably use the same time in the history. And this also should reflect all the changes in the time zones, in the daylight saving time, in the time zones since 1970. So it means that if some country or some region within a country had a different time during the past 50 years, it has to be reflected here. Where does the information come from? It is not Python developers who take care of that, because that's politics, that's not development. There is one organization who follows all of these time zones. So IANA.org, you go there, there are two things. There is a mailing list, a huge mailing list with a whole archive where people write about the changes of the time zones in the country, about the history. It's a fun reading. And there are releases of the visit data. So there is a file several times a year, between 2 and 20 times a year, there is a new release with the information that is actually released, and then it is converted to all programming languages, database systems, Androids, and so on. You see, this year it is quite quiet. We are at the second release, and the second release is actually very, very fresh. It is only 2 days old, so I had to check it yesterday for you. There are no huge changes, not relevant for Europe, but there is a new release. And you see that, for example, in 2009, there were plenty of new releases. Let's have a look at this file. So we download this file that is 2 days old, 390 kilobytes. And then what you see there are some codes in Perl, Shell, Awk that are used to convert. But what is more interesting are all these big files like Asia, Europe, North America, South America, Africa, Antarctica, and so on. And for example, in Europe, you see 180 kilobytes. There are two things. There is a code that will be converted into the time zone information that is readable by libraries, and there are all the comments that come from this mailing list that contain all the information about how, what, when, why happened, and where the news came from. If there is one picture from this talk that you would like to copy, take this. This is the history of all time zones around the world since the end of the 19th century until the near future. Turn your head to the left. On the x-axis, you see the years. On the y-axis, you see the offset. So 0 is Greenwich. To the top, that's east. So Estonia would be now at +3. Then there's Asia and Australia. On the other hand, to the bottom, -5, and so on. That's America. So you see at the beginning, all lines are just quite wild. Then they crystallize themselves into those more or less 25 time zones. And then the small ticks that you see, this is daylight saving time, introduced, abolished, introduced, abolished. There are some big jumps around the whole graph, and these are, for example, some islands in the Pacific that switched from the extreme east to extreme west by jumping around the whole day. And what you see, we are in 2020. The ticks, they go on until 2037, to the end of the 32-bit unique epoch. And that means that this is the current version, and if you use the current version, you test your code, you isolate it, and then you use it. This will just go on. So if, for example, European Union, Estonia, whoever abolishes the daylight saving time, using the current version of TZ data, PYTZ, you will your code will just jump to the daylight saving time end of March, and at the end of October we will jump back. This is a detail. The blue one is Berlin here in Germany, and the red one is Tallinn. So you see how it moved around in the history. Around 2000, you abolished the daylight saving time for a few years. Now you're reintroduced it again. For example, in the 1945, you see the blue line jumps to +3. It was at the end of World War II when, or after the World War II, when Berlin belonged to or used the Moscow time. So before 1970, this is very local. So if you have local time, the red line at the beginning is actually for Tallinn. So before Estonia or Tallinn introduced some Greenwich-related time, you were at 1 hour and 36 minutes, or the time that we have seen at the beginning, so 1.6, 1.7 hours ahead. And it was until the World War I. So this means that this was the local mean time of Tallinn. All the cities around before, they use their local mean time. So don't rely on this information for anything outside of the city that is uses its name for the time zone. And after 1970, it is guaranteed that this time is valid for the whole region. So Estonia used the same time later and uses it also in the future. Let's have a look at the code. So for example, here, Tallinn, you see the 1 hour and 39 minutes at the beginning, we use LMT, which is the local mean time. And then there was a Tallinn mean time renamed. And then there were some rules in the third column where you see that there are common rules for several time zones. And using this, you can see always which time or time zone offset was used. For example, the EU rule, this is general for the whole European Union currently, although Tallinn started using it only quite late. And you see, for example, in this rule, which is currently valid, are the last two lines. So since 1981 and 1996 in Europe, we use the daylight saving time between the last Sunday of March until the last Sunday of October. And there are comments. So, for example, here, the comments about the 1998 abolishment of the daylight saving time. There is someone, particularly, who wrote, I also asked my relative whether they use any standard abbreviation for their standard, and sometimes he says, no, they use Suvek and Talvek. So you see that people just write into the mailing list, and then if it is relevant, we copy it into the archive of the TZ data. So if you see that your government wants to abolish daylight saving time or move to some other time zone, you can write it and you will land here, and maybe a future one of me will give a talk about it. What I said about this summertime, wintertime, actually wintertime, no, that is summertime and standard time. Wintertime was used only once in the history in one country, and that was 1946 in Czechoslovakia. And on the 27th of November, they introduced the winter time. It means that in the standard time, we went even 1 hour back. So it was not daylight saving time, it was daylight wasting time. And they they decided that on the 27th of November, that from the 1st of December, so 3-4 days ahead, it will change. And then until the 23rd of February 47, it will stay 1 hour back. It was only once in the history, never happened again. But the law is still valid. And actually, the Czech or the Slovak government may declare the winter time at any time. This is the accumulation of all the daylight saving time offsets in Europe in the 70s and 80s. So what you see that this is the number of countries or in Europe, and you see that they introduced the daylight saving time slowly and on different dates. So actually, in those times, it was quite chaotic in Europe concerning the daylight saving time. Now it switches just constantly over. Let's have a look at some other time zones. In Africa and Central Africa, it's actually very boring. Ivory Coast, 1912, they switched from local time to GMT, and they stayed the whole time. And there are plenty of other countries all around that use the same time zone information, and this works like that in Africa. So it's quite boring. On the other hand, you have something like Morocco, which uses daylight saving time for Ramadan, and they declared all the months, all the years until 2087, with the note that please some future generations should update that for them. Istanbul, they use the daylight saving time concept of Europe, but in 2011, 14, 15, they just switched to daylight saving time in a day later or a week later. And that's a problem because you see that, for example, on the 10th of March, they decided that in 2.5 weeks, they are going to switch not on Sunday, but on Monday. If you have this information, it has to get to this data. It has to be released as a new version. It has to be converted into. You can imagine that how many problems people have if they rely on some computer IT software that is embedded. So, for example, if you have something like airplanes, you have a flight ticket that go from A to B, and it is always printed in the local time. So it was the case also in 2014. They also decided that they will switch device one day later. Having it on a flight from March 31, I can tell you that nobody, even the airlines, respected this time zone BS. They changed delay. They didn't just get out in time. No, if you announce it only a weeks ahead, this will not get out. Then there were some other combinations. They decided whether they are going to introduce, not introduce. Read the texts. It is not fun. It is actually quite problematic to read because you imagine that how many short-sighted political decisions changed our lives or the lives of people living in those time zones and using or that have to use the IT technologies. There are how problematic it can be. For example, Venezuela also 2 weeks ahead they decided they are going to advance their clock by 7 minutes. Port-au-Prince, this is Haiti. In summer they have 13 hours of daylight. In winter 11 hours of daylight, and still every year they decide, are we going to switch to daylight saving time or not? North Korea, South Korea in the 50s, 60s, for several years, everything that was external that stayed at plus 9 hours, but internal life switched to 8 hours and 30. North Korea switched to daylight saving time, or not to daylight saving time, but from plus 9 hours to 8 hours 30 in 2015, and also announced it only a week ahead. That's too late. So now imagine that we have this current version, and we want, or the European Union wants to abolish the daylight saving time. I ask you actually in poll what time zone you would like to use. I have seen the most of them, like half an hour ago, were for keeping of the Eastern European Standard Time and not switch. If that happens, all you have to do is just to take the 2 lines of rule for EU and then change this max to 2022 or 23, something in the future. Don't change this please this year, always change at least 1 year or even more ahead, and then it will work. So, time zones. Please never invent your own time zones. Don't hardcode any rules, something like, hey, is it the last Sunday of March, I'm going to do something. No, there are libraries for that. And keep your time zones updated. So I have told you that the second release of 2020 was released 2 days ago. Check what your computer has as the current version. Probably it is 2020A or 2021, like they are called. Keep them up to date. And follow your government's intentions to modify your time zone and write into the mailing list. And if you can, avoid the time zones. Thank you very much.
Thank you so much. It was very interesting, a lot of things that we don't usually think about. But I would ask everyone to just start sending in the questions then. Any questions that you have from Miro, again, you can just send them in the session Q&A, you can write them in the chat, or you can even write them in the Zoom chat if you are here. Let's see if we have something coming in already. I will also let you guys unmute yourselves. If someone wants to ask a question, feel free to unmute yourself and also ask a question if you're too tired to type it down. I guess there is a question that I cannot see. Let me refresh. Yes, so the question is, what is worse, keeping DST or eliminating DST and dealing with updating all legacy, embedded, etc. systems?
DST is not standard. If you use the electronic because it was introduced this data, you just don't use DST, you use the current time, and it is calculated from these time zone libraries. Your code should actually work with DST. It should know because of DST. It should just know what time zones are there and that's the question correct.
I think you would have to repeat yourself because connection kind of broke from your end. So there was like a lot of broken sound.
Okay. If I understood the question correctly, whether I should deal with DST, no, your code shouldn't deal directly with DST. You should use whatever is available in the time zone libraries. So if your legacy embedded systems use DST, they shouldn't be programmed, so you have to change them anyway. Yeah, before 1996, we had a daylight saving time in September, not in October. So if we have a program that looks to the end of September, it has to be changed. So you just remove all the functionality and
I don't know if I think the issue is not just from my end. I think your voice is breaking a little. I don't know if it's possible to somehow fix it or if it's a connection issue. It maybe just goes well on its own. We can.
okay. Okay, I'll disable him. So now is this better if I disable my camera?
Yes, now we can hear you perfectly. So
okay, sorry. Okay, so it was my camera actually. It doesn't, but okay. So again, keeping DST or eliminating DST. Actually, if you have some code that explicitly uses DST, what happened in Estonia 20 years ago? You had no DST. So if your code used DST at those times, it was wrong. So actually, what you should do is your code shouldn't explicitly code all these rules yourself. You should use whatever the time zone libraries give you for the information. And now it gives you the information that there is daylight saving time. But if it gets abolished again or moved something somehow, then you will have to use the information that is in those libraries.
Okay. I have also put in, there's also a few other questions in the chat. So there's one about why does replacing a TZ in a naive date time not use the current TZ, but the old historical one?
Yeah, because that was the case of the pytz. It is actually the implementation that doesn't do it correctly. That's a known bug in pytz, and because it is already known and everybody uses some workarounds to get it done, it won't be fixed. So if you use dateutil or use the new zone info, you won't have that problem. So just forget about pytz and use the new zone info or dateutil if you have older Python.
There's one about what is the most common mistake regarding time zones that might cost dearly later.
Don't do things implicitly. So if you have for example, never use datetime.now alone. You use it always datetime.now with the time zone information. So if you use some datetime objects, always put the time zone information to it, add it to it. The only exception is if you have some future dates. So for example, if you tell me that the PyCon Estonia in 2021 will take place on the 9th of October at 10 a.m., write it somewhere, not using the TZ info, write it in the TZ naive datetime, and add the information only in text that it will be in Tallinn, because if Tallinn changes its mind and you still want to keep it at 10 a.m., probably this timestamp in the future will not be the same in UTC as it is now. So if you are working with present and past events, always put data object with TZ info, and if it is something in the future, use it a wall clock without time zones. So yeah, so actually one big mistake is if you don't do it correctly, what I just explained. Yeah.
Perfect. Is it better to have fixed time and example adjusting schedules to save daylight and honor the time formula plus minus 15 fluctuations?
Well, I don't understand this plus or minus 15 minutes. What are about these 15 minutes? Because they have nothing to do with. Okay. You were. Okay, about this time with the fluctuations, this is this time formula, yeah. The solar noon, you can ignore it because you would have to make the seconds faster or slower every day. We just cannot respect the sun exactly. So if you want to have some time that is worldwide valid, we just have to ignore the solar time, and these fluctuations will have to be ignored. So, and the daylight saving time has nothing to do with these fluctuations actually. So we just use it as we have now UTC, and then around the world with those 25 time zones, and it's okay. So yeah.
Okay, perfect. That's all the questions that I have received. If I have missed anything, feel free to write in the chat or unmute yourself, or you can even tweet later and you get to Miro, or you can also write in the community chat and hopefully he can see it today. But thank you so much, guys. Okay, we can take one person has asked, can you explain where do you work and how do you know so much about time and Python at the same time? Maybe we can, end on that.
Yeah, I work at Zolute here in Karlsruhe. We don't do that much with times, but in my previous job, I worked a lot with time series and with the observation, physical observation, meteorological observation from all around the world. And I had a lot to do with daytime information that was incomplete, where the people who gave us the data, they just didn't know which time zone their sensors are in the data. So that was quite a lot of motivation to learn more about it, about these time zones. And actually, it's interesting. It's really, as I started reading all these comments in the TZ data library, there is so much fun. It is not fun actually. It's frustrating to know that there are people in the world who decide about our time zones. But it's really interesting to learn about the history of those countries. And actually, I learned quite a lot about the history of Estonia or about their time measurement. Yeah.
Perfect. I think it was a very interesting talk. Thank you so much, Miroslav, for your time. Thank you, everyone who was here for the talk. And
thank you very much for having me.
Yes.